In 1917, a new spirit was blowing through the streets of Calcutta. The grand capital of British India and the jewel of the empire was stirring with revolutionary activity. The partition of Bengal in 1905 had reinitiated a movement to free India. At Calcutta University, a very different revolution was underway. A revolution in science. Indian science had a long and rich history. India had given the world the zero, Sanskrit, yoga, Ayurveda, and two of the world's first universities at Nalanda and Taxila. But then, from the 11th century, India entered a dark age with the destruction of great learning centers by invaders. By the time the British colonized India, it had lost much of her once cherished scientific vigor. Then, from the 19th century, a new age of enlightenment began, and Calcutta was the epicenter. This was the Bengal Renaissance. Roy founded Hindu College in 1817, educating Indians in English for the first time. This was later renamed Presidency College by Thomas Babington Macaulay. Then, Lord Canning established the University of Calcutta in 1857 to educate citizens of the empire from Lahore to Rangoon. When Ashutosh Mukherjee became Vice-Chancellor in 1906, he began working on Roy's dream of a science college. In 1914, with generous donations from Sir Taraknath Palit and Sir Rash Behari Ghosh, he launched the University College of Science and Technology. Meanwhile, at Presidency College, two young MSc students were making waves. Satyendra Nath Bose and Meghnad Saha had stood jointly first in their MSc examinations and were ready to take on the world. Around the corner, at the Indian Association for the Cultivation of Science, another young scientist, C.V. Raman, was creating a stir with his experiments and papers. Mukherjee realized that in order to make his science college great, he would need people like this. Meanwhile, a very different revolution was taking place in Europe. The old physics of Newton and Maxwell was being turned on its head. Max Planck came to the conclusion that energy was being let out in discrete energy quantities or particles. He called these particles quanta. The equation came to be known as Planck's law. This was the beginning of the quantum age. Then, three amazing developments occurred. Einstein demonstrated that light was both a wave and made up of particles he called light quanta. Lord Rutherford discovered the solar system model of the atom, with a dense positive nucleus and electrons spinning around it. And finally, Niels Bohr demonstrated that those electrons could only move at the quantum energy levels predicted by Planck.
So these three great shots in the dark had already been made when Bose entered to fire the final and fourth great shot in the dark.
Satyendra Nath Bose was born in Calcutta in 1894. His childhood was immersed in art, culture, music, and education. He demonstrated a flair for mathematics very early on and amazed his teachers with his abilities. When Bose got to Presidency College in 1910, he studied applied mathematics with Saha. Those were heady days, and many young men were drawn to the freedom movement.
P.C. Ray used to meet them at the bottom of the Octonony monument in the evenings, where they would discuss the future of the country. Two groups were formed. One went into direct action. The other group said, no, we will not go into direct action. When we get independence, who's going to do all the science and technology, and knowledge is essential for progress.
Bose stood first in his BSc, and then he and Saha took a joint first in their MSc examinations. When Mukherjee founded the new University College of Science, Bose and Saha jumped at the chance of teaching there.
So these young guys went and convinced Sir Ashutosh that they were competent to start the physics department. Most of the important papers were being published in German and some in French. So they learned French and German.
The brave new world of theoretical physics was unfolding a whole new universe.
And they were the first people to actually translate Einstein's papers on relativity into English. And it was published by the Calcutta University. So they were making waves, and they were voracious readers and superbly intelligent people.
To further his career, Bose moved to East Bengal in 1921 and became reader at the newly founded physics department of Dhaka University. In 1924, while teaching a class on quantum physics, Bose had a eureka moment. Bose had been very dissatisfied with the way Planck's law was being derived in Europe. Earlier, Ludwig Boltzmann had developed a mathematics using probability and statistics to predict how gases worked in a closed thermodynamic system. Bose realized that he could apply statistics in a novel way to predict the number and probability of Einstein's photons using Planck's equation in the same way. A new statistics would be needed that could work at the quantum level to count photons. This was Bose's great breakthrough.
What he showed was that in the case of photons, classical statistics doesn't hold. It's a new statistics, which is now of course called Bose statistics. So there are new kinds of objects which people were not aware of. So the first paper was called Planck's law and the light quantum hypothesis.
He sent his paper first to the Film Mag in Britain, but it was turned down. And then, in one of those seminal moments in history, he decided to send his paper to Albert Einstein. It was a bold decision and became one of the great moments in modern science. Respected sir, I have ventured to send you the accompanying article for your perusal and opinion. I am anxious to know what you think of it.
So Einstein was delighted. He said, this is what I was looking for. So my photons are not like classical billiard balls. They are bosons. And so overnight, Bose became a very, very famous name in the world of physics.
Einstein then sent a postcard to Bose saying his work was a beautiful step forward. When Einstein's postcard arrived, Bose became an overnight celebrity and was immediately granted permission to travel to Europe to meet Albert Einstein.
So in the first year, he actually spent a lot of time with Maurice de Broglie, who was setting up the X-ray crystallography lab. And then he worked for 6 months with Madame Curie.
He proceeded to Berlin the next year. And in addition to meeting his hero Einstein, he also met some of the leading theoreticians of the age.
Einstein was so impressed, he said, Bose's way of counting should not only apply to photons, it should also apply to material atoms. That was Einstein's extension of Bose's idea. You get a quantum gas of material particles, and finally, that at very, very low temperatures, everything can condense. If all the particles condense into the lowest energy state, then you have a new state of matter, which has now come to be called the Bose-Einstein condensate. Now in 1928, Paul Dirac wrote a very famous book called Principles of Quantum Mechanics. And in that book, he coins the two words bosons and fermions. So, you can say that half the particles in this universe are bosons. And as somebody said, as long as there is light in this universe, there will be bosons everywhere. So one simple idea in Dhaka completely revolutionizes everything, and then, of course, Bose becomes a household name, or rather boson.
Bose returned to Calcutta University in 1945. He founded the new organic chemistry labs and also worked on trying to solve the unifying theory of physics that Einstein had been working on.
So Einstein used to call it the unitary field theory. He found it very odd that there were both waves and particles. And he proposed a theory which would do this. But there were various objections, and Einstein started communicating with him again. And Bose wrote this paper and was very eager to go and actually discuss this with Einstein. Einstein passes away before the meeting takes place. And the story is that when this news arrived, he simply tore up that paper and threw it into a waste paper basket. So there is this unfinished symphony hanging there.
Rabindranath Tagore dedicated his seminal work on science to Bose after hearing about him from Einstein. In 1956, Bose became Vice-Chancellor of Tagore's newly created university at Shantiniketan. The vision was to bring about a scientific revolution in Bengal, but Bose faced obstacles from the status quo at every turn, and after 2 years he returned, frustrated, to his home in Calcutta. But things turned around that year, and Bose was finally inducted as a Fellow of the Royal Society. And then, in 1959, in recognition of his achievements, Prime Minister Nehru appointed Bose the first National Professor of Physics. At that time, Bose had started teaching at the Indian Association for the Cultivation of Science, which Raman once had made famous.
Finally, on July 4, 2012, scientists working with the Large Electron-Positron Collider and Large Hadron Collider at CERN in Geneva announced the discovery of the Higgs boson particle. Despite all of the groundwork laid by Bose way back in 1924, for what is called the greatest scientific discovery of this generation, Nobel Prize in Physics was never awarded to Satyendranath Bose. However, on the year 2013, Peter Higgs, a British scientist, eventually won the Nobel Prize for the Higgs boson particle.
People sometimes tell that Bose didn't get Nobel Prize. But how many Nobel Prize winners' name are learned by every physics student?
Bosons are so fundamental, Bose statistics is so fundamental in modern physics that it's one of its cornerstones. The whole edifice would simply collapse without it.
So, what was Bose's great contribution to physics? Well, without Bose's statistics, we would not have been able to count photons and predict their behavior. Nothing we take for granted today, like lasers, fiber optic communications, superconductors, or the future in quantum computing, would have been possible without Bose's counting methods. And without bosons, we would never have understood how matter came into being after the first few moments of the Big Bang, or what makes up most of the universe at the quantum level. He also dedicated himself to making science available to Bengalis in their mother tongue. This became his life's mission. Bose spent the rest of his life teaching at IACS and his room at home, managing the Science Association of Bengal, meeting people from all walks of life, playing the esraj and the flute, discussing philosophy, and teaching young minds about the new frontiers of science. Finally, on the 4th of February 1974, Satyendranath Bose passed away, and it was said that with his passing, an era ended, an era of great men who created science in India.